All right, our final installment of 10.7, the last new material you got to know for chapter 10. The root test. Let's go. So our root test is let the sum of our sequence be an infinite series. And we're going to call this little row, by the way, that's row. Little Greek letter, you see it a lot in Calc 3. And we'll say let the row just be the limit as k tends towards infinity. And we're just going to take the kth root. See this? That's what's going on. We're going to take the kth root. Hence why it's called the root test. So as before, remember how we called it R before? Now we're calling it rho. If it's less than 1, the series converges absolutely. If it's greater than 1, including infinity, the series diverges. And if rho is equal to 1, the test is inconclusive. So we're just going to need to take any sort of sum. And if we see a lot of exponents in there, we're like, well, shoot, this might be a great spot to start. So let's check it out. So we are in this section, so it's telling us directly, just in your homework, your test, it will not tell you, use this test. No. It's going to say evaluate. Tell me whether it converges, diverges, absolute, conditional. What's up? So we're only going to find out whether this converges absolutely or it diverges. That's the only two. Well, and it could also be inconclusive as well. Okay, so what we're going to do, we'll set that thing up, and we're going to say our rho is equal to the limit as k tends towards infinity of the absolute, so it's the kth root, and then we take the absolute value of our sequence to the kth. Now you can see what's going to happen here, huh? A kth root to the k? Get the heck up out of here, huh? Thwack, thwack. Those are just going to cancel out. So we're going to be left with the limit as k tends towards infinity, and then we have the absolute value. Now remember that k's are going to start at 1. And we can only have positive things in there. So if k is equal to 1, did you know the absolute value of 3 minus 4k squared? If you were to just plug that in, we would get a negative 1, and then we'd have to change it. But this is the same thing as 4k squared minus 3. That's changing the signs on both. That's changing the signs on both to ensure that it's always positive. So we changed that. That's kind of a weird little step there. I know it is. And then the denominator, well, that's going to just stay as a positive because, come on, man. Because, come on, man. You know? So once we get to this part, we're like, well, wait. Oh, I forgot my square, didn't I? Look, there's a square there. I was like, this is going to diverge. Oh, there we be. There we be. So now we look at it, and you probably scream and go, there's a square on it. Put it there. Yeah, no. So our leading terms are right here. We can ignore the rest, and hence we get 4 over 7. Now, 4 over 7 is less than 1. Therefore, we converged. Absolutely. Yep, we have absolute convergence. Did you catch all that? How's your algebra, dude? How's your absolute values rolling? Because you're going to have to play some games with some absolute values through this because it's inside of there. This little step right here, recognizing that, and I should say for k, just greater than or equal to 1. Works for 2 and 3 and 4 and 5, right? We have to make sure that we get positive outputs, no negative outputs. Now, a little trick. Not talking to you as a teacher, but let's say you forgot to do this, and you're like, it's 3 minus 4k squared, you did your work, and you found out you had negative 4/7. Just take the absolute value of it and be like, dude, it's less than 1. That's another way of doing it, so if you don't really see it, you're like, oh, I got a negative, but I know everything needs to be positive. You'll be good. All right, let's do one more, and then let's wrap it up, and then we'll do a whole big old wrap-up. And I'll give you an example of what you might see on a test where I give you a few problems and say, hey, you're only allowed to use each test once. You can only use each test one time and one time only. Okay. So let's tackle this one. We see we have some powers. One is a k, one is a 10. Okay, well, it says to do the root test, so I'm going to do the root test. It tells us to take the limit as k goes to infinity of the kth root of the absolute value of this stuff. These thingies here, huh? So this is our negative 2 to the k over k to the 10th. Well, the kth root, well, let's write it a little different. I don't like writing it with roots like this. You know what I mean? I don't like writing them. Oops. That means two different things. I gotta make sure my absolute value's in there. It's something completely different. I'd rather look at it like this. 1 over k. And it's up to you how you do it. And then we can kind of distribute these into both. Oops. These are absolute values. My bad. Got to make sure that those absolute values are handled. So once we bring this in, we're going to have k over k. So this is just going to be left with the limit as k goes to infinity, the absolute value of negative 2 over k to the, now we're just going to divide by that k on this power. Goes 10 over k. Do you know the absolute value of negative 2? Of course you do. Of course you do. K goes to infinity of positive 2. And now I'd like to write this. K to the 10 over k. Is this true? Is that true? Is that k to the 1 over k all raised to the 10th? I think it is. Pretty sure it is. So where's that go? Do you see it? Well, now I'm going to take you back to, let's do Calc 1. Let's go back to Calc 1, how we tackle something like this. This is the same thing as 2 over something raised to the 10th of the limit as k goes to infinity of k to the 1 over k. Those are limit laws. That's how, sorry, my voice is cracking. Puberty, haven't quite finished it up yet. You got to figure out what that is. We're just bringing our limits inside of a function. It's all that work we did in Calc 1 to make sure we were pro. So we're like, all right, well, what is this? What's the limit as x tends towards infinity of x to the 1 over x? I'd rather tackle that just to see where does this limit go. And you can make them all k's. I just moved it to x's because technically we're not allowed to do this with natural logs and things like that. So we would say that this is equal to e to the limit as x goes to infinity of ln of our x to the 1 over x. So we can just call this is going to be our e to the l. And l is equal to the limit as x tends towards infinity of ln of x to the 1 over x. The 1 over x falls. That's the reason why we had to use the ln. If you're using online homework helpers to help you solve these, that will not work on your test when you have to take it in person. So if you're continually using those methods that only computers use, humans do not use them, I think you're going to be F-worded on your exam. So please make sure that you can do limits in the manner that you were taught in Calc 1, not by what a computer does. So we now have an infinity over an infinity case. We get the limit as x tends towards infinity of 1 over x over 1, which is the limit as x tends towards infinity of 1 over x. Where's this go? This goes to 0. So we pop it back in and we're like, oh, this is actually 0. E to the 0th is 1. So we just solved that. We can pop it back in. So now we look and we're like, well, we have 2 over 1 to the 10th, which is equal to 2. So our rho is equal to 2, and that's greater than 1. Therefore, this diverges. You could have also done the divergence test. You could have done the divergence test and you would have found out immediately, like, no. Or you could have used a little bit of logic up top. Original problem. We're going to deal with the absolute values. What grows faster? An exponential function or something to the 10th? At the beginning, something to the 10th is going to grow faster. But dude, once you get to like k equals like 5, no, it's still not there. Maybe k equals 12. All of a sudden, that numerator is growing faster than the denominator. So a little game like that could have helped you out to see it. But yeah, there is your root test. Probably the least used, that and the alternating series test, probably some of the least used stuff that we do. But ratio's big. That's a big one. Ratio's big, comparison's big, divergence and integral tests are big. Root's kind of small. Alternating series, you can kind of see it before it happens. Yeah, buddy. So I will see you in the next, we'll do this 10.8, and it's called choosing a convergence test. We'll kind of figure out, like, what do we use when we're not told use the root test, use the ratio test. And that's what we need to be pro with. So, all right. I will see you in the next section.